Hello. So, this is the project that me and my teammates have been working on for the past week, and we're basically almost done. And I'm going to be demonstrating everything that we have achieved so far and like finished doing. Okay, so this is the file estimating the heating load based off 8 features, which are the relative compactness, the surface area, the wall area, the roof area, overall height, orientation, glazing area distribution, the heating load, and the cooling load. So, to do the things that we're supposed to do, we're going to have to import all the libraries that we need, which we do right here, and then we read the .csv file, which has been cleaned prior to loading it, and it has also been renamed to the cleaned database file. Yeah, where we actually like did all the renaming and the clearing of the data. So after that, we get the information from data frame, like rows and data types present right over here, as you can see. And then we create a scatter plot between every column using Seaborn library, which has been imported previously right over here. Okay. Then we compute the correlation coefficient between every column and display them as a heat map using the Seaborn library. You can see the output right over here. And then we copy the original data frame and picking the columns of interest. Okay. We convert the futures column into standard units. This is the code doing it. There's quite a bit. And then we output the head as well, the first 5 columns. The first 5 rows. To make the model, we first randomly shuffle all the rows without replacement right here. We separate the futures and response variables between the training set and test set. Then we transpose and stack them into a row of ones vertically. Rows of ones vertically right over here. This is the code to do it. We define theta as an array of zeros and then implement the gradient descent algorithm right over here. The gradient descent algorithm contains the hypothesis function, the cost function, and the derivative of cost function. We then test the model on training and test set, and then we plot cost function versus number of iterations. Right over here. We then test the model on training and test set, then we plot cost versus number of iterations. And lastly, we calculate the errors for the predictions. So that was the heating load file. The cooling load file is basically the same as the heating load file with one key difference, and that is the heating load column has been dropped. Next, we also implemented the predictor function. For that, we started off by importing these 2 libraries that we're going to need, and then we also read the dataset, the cleaned database that we previously did as well. We select the relevant columns. Right here we calculate the mean and the standard deviation. We also print the mean and the standard deviation, and then we go ahead and start defining the function. We name this function the estimate heating load. This is the function for the heating load. We also have a function for the cooling load as well. So we get the user input, and we take all the variables that we need, which are the surface area, the wall area, the roof area, etc. We then standardize the input values, and then theta values from the gradient descent model is right over here, and then we compute the estimated heating load using this code right over here. It's just like a basic matrix multiplication. Sorry for stuttering so much. And then we just return the heating load, which is done right over here. We can like also print the values if you want. Next up, we do the exact same thing. We read the data set, we read the relevant columns, we print the mean and standard deviation instead. And the one difference is that the function this time is going to be estimating the cooling load instead of the heating load. And you can see almost everything here is the same as previous function, except we are estimating the cooling load. So that is about it. Thank you so much for watching. This was Yash.